Because what you don't know about energy can kill you. Here's Alex Epstein.
Welcome to Power Hour. I'm Alex Epstein. Well, over the last 2.5 years, I've been working on a new book called Fossil Future that I'm wrapping up now. And several times as I've been thinking about various issues, I've been thinking there's one guy I'd really like to talk to because he has a lot of insights about these issues. And he was one of my favorite Power Hour guests when I brought him on several years ago. His name is Ross McKitrick, and he originally became famous for, in my view, debunking what's called the hockey stick, which we'll talk a little bit about today, and we talked about a lot the last time I had him on the show. But he's also just a very smart, thoughtful economist who has lots of interesting things to say about energy, about climate. And I think in particular, he has very good standards for different things. So I trust his judgment a lot, and I'm very eager to bring him on the show again and to ask him a bunch of questions. So Ross McKitrick, professor of economics at the University of Guelph, welcome back to Power Hour.
Thanks, Alex. Happy to be back.
All right, we talked about the hockey stick years and years ago, but I think that in case people have not committed that episode to memory, I want to at least get a little bit of background. So can you summarize, I'm sure you've had to do this many, many times, but what happened with the hockey stick saga and sort of how that's evolved or devolved through today?
Okay, well, in the earliest versions of the Intergovernmental Panel on Climate Change reports, they were looking for evidence of unusual warming in the 20th century. And one of the difficulties they had was there's a lot of evidence the world was also warm in the medieval period, especially the Northern Hemisphere, especially Europe and places like that, and North America. Lots of indications that it used to be at least as warm, probably warmer 1,000 years ago. And then in 1997, 1998 and 99, Michael Mann and a group of co-authors, a climatologist, Michael Mann, published a study putting forward a reconstruction of the Northern Hemisphere climate that suggested, no, it was actually very flat for about 800 years. And then beginning around the time of industrialization, temperatures began going up, but there was no medieval warm period. It was just like a hockey stick graph and a hockey stick shape. I guess starting about 20 years ago, there's a retired businessman in Toronto with very good training in math and stats, a guy named Stephen McIntyre. And he'd worked with a lot of geologists. He understood about temperature proxies and these climate reconstructions. And he began trying to figure out how the hockey stick was put together. And he emailed me at one point and showed me what he was working on. And I thought this was really interesting, really valuable. Nobody seemed to understand how this hockey stick graph was put together, but Steve had managed to decode the math and was doing some plausible reconstructions, but also finding mistakes in the methodology and questionable data handling. So in 2003, we published a study, and our argument was there were some serious methodological errors and some questionable decisions about how to handle the data. And if you back those out, the graph really didn't look like a hockey stick. It didn't give support to the author's conclusions about the 1990s being the warmest decade of the millennium. That then triggered a huge controversy. It led to ultimately hearings in the US Congress. A panel from the National Academy of Sciences was put together. A lot of work was done. We published a series of papers in scientific journals, and we did show that the Mann technique was flawed. There were errors or questionable judgments, and that essentially the data just didn't allow you to say something as precisely as what they were saying, that there's way too much noise in the data, and you couldn't say that the world today was much warmer than the medieval warm period. That literature has kind of gone on from there, but ironically, the issue is still alive because there are defamation lawsuits still grinding through the courts. Michael Mann has sued a bunch of other people who he didn't like how they described his work and how they criticized him. But the essence of breaking that stick was showing that the methodology was flawed, and that then raised I think, as big a question, which was, how is it that this study became the headline conclusion of the Intergovernmental Panel on Climate Change at a time when they were bragging that they had thousands of scientists and they reviewed everything very carefully, and the scientists all re-examined the data, and they had this incredibly rigorous peer review process. And then it turned out, no, they hadn't looked at anything. They had no idea how this graph is put together. They just liked the conclusion. And because of that, they made it the front piece of the third assessment report, based all their conclusions on it. And yet neither they nor any of the sponsoring governments had ever done any due diligence on this study. So, and that has been an issue that I've, even though I don't really work on paleoclimate issues now, I find remains a big problem in the way that science is used in the climate area. Governments and the IPCC itself, they know the kinds of results they're looking for. When they find them out there, they splash them around as headline studies, even if they're brand new in the literature, and they don't do the kind of due diligence that people think they do. There's very little serious replication work and serious reexamination of studies when the results look just too good to check from the IPCC's point of view.
That's a good expression. Too good to check. Now, Mann, when Mann writes about this, so he's done this multiple times, but let's say it's this popular book called The Madhouse Effect. And he, his version of it is, this has been vindicated. And he has this cute term where he'll say, oh, there's now a hockey team. Like hockey stick was considered, aberrant, but in fact, everyone now agrees with this. What's your assessment of that claim?
He can point to a bunch of studies that all came out last decade, which one way or another they managed to say, yeah, there's a bit of warming in the medieval period, but not quite as much warming as we've had now. So the present world is warmer. Again, digging into the details, one of the big problems was they tended to reuse all the same data. And a lot of those studies actually used the incorrect math that was in Mann's study. The report called the Wegman Report, which was commissioned by House of Representatives Committee, Ed Wegman and a couple of his colleagues from other statisticians at George Mason University. They had a chart in there showing that, okay, it's deceptive to say there's all these other studies that apparently vindicate the hockey stick, because they all reuse the same data and most of them were using the same flawed methods. And when you got into other studies that really worked independently, then you don't get that unanimity, obviously. And also, I think the more important approach was a pair of statisticians, McShane and Weiner, who had no background at all in this field, but were drawn in out of curiosity. They looked specifically at the statistical methods. And their point was, you can take these same data sets and put them together a bunch of different ways, and the statistics won't let you choose which reconstruction fits the data better, but you get such a wide range of results. You can basically pick any history you want. And I think that's where things stand as far as the statistics goes, that, okay, sure, if what you want is a half a dozen hockey stick graphs, you can get them. But you could take the same data and analyze it a different way and get completely different results. So what the data is really telling you is it's too noisy and you can't draw strong conclusions. And I think in general, it's much safer to look at specific locations where you have a tighter connection between proxy records and temperature series in that single location. And when you do that, well, a lot of areas in the world, including here in Canada, the medieval period was strikingly warm compared to the present. And I take your point that for a lot of people, their dodge on this is, okay, well, there's now a whole bunch of other studies that backed up the hockey stick. And I would just say, well, not independent studies and not studies that had robust statistical results in them.
I mean, well, actually, I want to comment on something and ask a little bit more about it. So you mentioned this, well, I'll put it this way, is like, I think of it as a failure of what I think of as like the climate knowledge system. So I think of the knowledge system as everything from the research to the dissemination to the public.
Mhm.
We had this thing, and then that includes the synthesis by IPCC or by National Climate Assessment. And, it definitely has the portrayal as this objective process where we're really getting the best thoughts of the scientists communicated. But this thing with like this completely, I mean, I think completely bogus or close to bogus methodology became the takeaway conclusion, and was sort of quietly, it's no longer the takeaway conclusion. Like it's a real failure of the system, and it shows real biases in the system. What if anything has the IPCC done to correct this kind of failure?
Um, the short answer is nothing. They did commission a group called the Inter-Academy Council, I think it was called. In the aftermath of ClimateGate, they asked this international academic body to review their procedures and go through and make recommendations. And so this body took evidence. They talked to a lot of people. They heard a lot of complaints, including from a lot of participants in the IPCC, that have become very political, and the selection of lead authors is really where a lot of the manipulation takes place. So the IPCC itself is it's a government body. It's government delegates who meet and then give direction to the working groups that do the scientific and the research assessment work. And it's at the stage when they choose who are going to be the lead authors for a coming report. And the field is such that if you pick certain names, everybody knows what the conclusions are going to be. And it hardly matters at that point what the papers are that they review or what they say. And that was an area where the recommendations were explicitly, you have to get a wider range of scientific opinion, and you have to document carefully how you're taking account of the range of scientific opinion. And those kinds of recommendations just fell on deaf ears. I don't think that the process has been reformed the way it should have been. Even the existing rules do impose requirements on them to document the full range of scientific opinion on these issues, and also to make sure that during the review process they pay attention to reviews, comments from all the different perspectives. But what inevitably happens, it comes down to the honor system. So the lead authors get the final word, and they don't have to make any changes if they don't want in response to review comments. And even though there are review editors, I mean, some of your listeners may, if they're familiar with the rules, they might say, no, wait a second, there are review editors who are involved who are supposed to enforce that. And the problem is they don't. And this has been documented by IPCC critics. The review editors, they just kind of glance over and make sure that the lead authors tick the boxes and indicated some kind of response to the comments. But lead authors and chapter lead authors do the reviews. They're reviewing their own work and that of their critics. If they decide that they prefer their own results to their critics, that's the end of the story. And the whole review process in that sense is a bit of theater. So they can go out afterwards and say, well, look at all these people who are involved in reviewing the document. But really, it was just what the lead authors wanted it to say is what it ends up saying.
Gotcha. Is it you mentioned that there were a bunch of researchers who complained. Are those complaints documented anywhere?
Yeah, the Inter-Academy Council, it's actually so long ago now that I've begun to forget some of these details, but they put out a report, and there's a Canadian journalist named Donna Laframboise who dug into the report and the online appendices and pulled up a lot of really surprising written feedback that they were getting about the complaints about the process and the politicization. And around the time, I also put out a paper for the Global Warming Policy Foundation in the UK, where I talked about problems with the IPCC process and how I thought it should be reformed. And I excerpted from some of those comments. And I think now what would be kind of interesting is to go back and see what were the recommendations of the Inter-Academy Council that were given to the IPCC, and did the IPCC actually make any reforms to its process? And I think you'll find that no, they didn't, or there might have been a few cosmetic reforms. But the special report on warming of 1.5 degrees, I think, is a good exhibit for understanding what's wrong with the IPCC and what's wrong with relying on it, because that exemplifies everything I've mentioned. They took a small group of lead authors. As far as the economics goes, these are people who were not involved in writing the economics chapters of previous reports. That group put out some very different conclusions about the future projected damages of greenhouse gases. Radically different statements and conclusions. And they were based on just a couple of papers that were brand new in the literature and hadn't been tested, hadn't been really examined. And in the years since, those studies that they relied on haven't held up very well in the literature. But nobody goes back to revise those earlier reports. Although there's certainly work of the IPCC that I admire, and I think on the physical science side, a lot of their chapters are basically sound, and it's where I would tell people to start if you want to read about this topic for the first time. Start with the physical science reports and the chapters, and but on the issues now that get closer to the policy side, where you're looking at the projected damages of global warming and the problems of 1.5 or 2 degrees warming, there I think we're seeing these problems amplified quite a bit.
So I'm curious what you think of the following. I mean, I don't know if you know this. My primary background is philosophy, so I'm really including moral philosophy. So I'm very interested in what standards are people using when they're evaluating things, including when people say things like, "Oh, we've destroyed the earth" or "the world is bad." You know, what standard are they using?
Yeah.
And I think in general, people are in the environmental movement are using the green standard, which is the idea of we shouldn't impact nature. You know, nature should exist as in an as unimpacted a state as possible. And I see one you mentioned the 1.5 degree report. This is what brought this up. You know, at the outset of this report, they have a summary of like the state of the world and fossil fuels relationship, and it's very close to like a half a sentence where they acknowledge something like, yeah, it's gotten better in certain ways, but it's bad in a lot of others, and there's inequity and stuff. And, you know, you talk about hockey sticks. I talk about the human flourishing hockey sticks of, you know, population, and, you know, income and life expectancy, you know, all in this, you have a hockey stick of energy use, not coincidentally correlating, but they can take a world where, for example, since I was born in 1980, poverty, $2 or less a day has gone from 42% to less than 10%. And they can describe that as the world is getting worse. And to me, that shows that there's just a fundamental lack of valuing of human flourishing and the whole IPCC. And the whole focus is it's bad for us to impact nature. It's bad for us to impact climate. And I regard that as a very deeply kind of primitive religious perspective that permeates the whole enterprise. I'm curious what you think of that.
Well, you touch on a strange, I think it's a bit of a contradiction right at the heart of what they are doing, because implicitly they're saying the ideal state of nature is absolutely untouched. Whatever it is in the absolute absence of human beings, that's what it ought to be. And any modification that we make is a move away from the optimum. And so if they're worried about global cooling, they'd say a cooling of 1.5 degrees is a disaster.
Right.
If they're worried about warming of 1.5 degrees is a disaster, but only because it's us doing it. If they look through geological history, of course, well, an ice age rolling across the North American continent and wiping out all the forests and doing incredible damage everywhere, they would say, there's nothing wrong with that. That's just nature acting on itself. So if it's nature doing the damage, if it's a volcano that rips a mountain apart and destroys forests for 10 miles in every direction, there's nothing wrong with that, because that's nature just being nature. And we don't see any problem with that. But if it's humans doing it, then no matter what we do, it's a problem. And I think the word for that is anti-humanism. Because if in the process of clearing out forests and extracting minerals and fuels from the ground, we've made life better for human beings. You're right. There's a lot of people in the climate field, the environmental science field in general, who would look at that and say, it doesn't matter how much better it is for humans. We've changed the world, so it was a bad thing to do. They might not come out and say it in those exact terms, but you get the subtext in documents like the IPCC reports, where every change is just described as bad. There's nothing good that they can say about CO2 and global warming. Actually, no, let me take that back. In the main assessment panel, the working group 2, it would be called, in its past reports, they often said, a moderate warming of up to 2 degrees or so would have a lot of benefits for a lot of places around the world, and on balance wouldn't be a problem. And it was only the SR 1.5, the report I mentioned on 1.5 degree warming, that threw that out and argued for a very different point of view. I just wrap up with one observation, which I think, again, goes to the incoherence, which is, I think if people want to argue that nature is the moral ideal and no changes can be allowed to nature, and at the same time then say, and by the way, humans themselves are just a part of nature, then anything humans do is natural. And it's a point that I encountered years ago reading some environmental philosophers who were trying to understand, okay, what is the moral argument for environmentalism? And you run into this problem that, okay, if we're going to view humans on the same plane and being worth no more and no less than nature, then everything humans do to their environment is natural in that sense. And so we have no basis to criticize it. If you're going to try to construct a basis for saying that the actions of humans on nature constitute an immoral action, you either place humans above nature or you place them below nature, but you can't have them on the same level as nature. And I think the default position of a lot of students who are really steeped in environmentalism gets dangerously close to saying, well, humans are actually worth less than nature and the world would be better off without humans. And at that point, I guess I just part company with that line of thinking. And I think it's a dangerous path to trod, because you end up with an anti-human stance.
Since you're mentioning that, I just want to bring people's attention to one of my favorite writings of yours, which you wrote in 2009, called Earth Hour, A Descent. So if you search Ross McKitrick Earth Hour, you'll see it. But I love the beginning of it. I abhor Earth Hour. Abundant, cheap electricity has been the greatest source of human liberation in the 20th century. And it goes from there, but it's really talking about how, low cost, reliable energy, and then electricity in particular, just makes the world a much better place for human beings to live. But I like the moralism of it, in terms of I abhor Earth Hour, because it poses as righteous. And if you want to get the core of the movement, I mean, it's saying, hey, let's spend 1 hour where we're really moral, where we don't do anything. Like, right. Is really their standard is unimpacted nature. It's not human flourishing. And it really shows how anti-human it is, because it's like not a coincidence. Oh, you can only do it for 1 hour, but it's like, oh, this is the ideal. So I think that reveals it. Let me move to a topic that is somewhat related to the hockey stick issue, but I have more confusion over, which is this issue of climate models. You've done a lot of good work on climate models. And I say there's a parallel, because just as Michael Mann claims to be vindicated on the hockey sticks, so there is a narrative that, climate models have performed amazingly well. And therefore, when we hear, projections of radical warming in the future, even if it's only been 1 degree Celsius in the last 170 years, or however you want to measure it, like, in the future, it might be 4.5 or 5, and that could be in the near future. What's your take on sort of what climate, sort of what has been the track record of climate models that project extreme temperature increases in the future?
Well, this is an area that I've published a fair amount on. Coming at it as an economist, I have a lot of training in econometrics and time series analysis, although I'm not a specialist in econometrics. The whole time I've been working in the climate field, though, I've noticed that it really comes down to data analysis. It's a lot like economics in the sense of what you have are large data sets, and people are arguing over how to analyze the data sets. And within the climatology field, they don't tend to have a lot of specialized training in statistics and econometrics. So I have worked collaboratively with people in the climate fields, bringing econometrics to bear on some of these issues. And one of those issues is, okay, you have models, not just projecting the future, but models reconstructing the past. And we also have the observations for the past. And how do you compare them? And can you say that the models are significantly off the mark as far as their reconstruction of the past? And if they are, then that would indicate, okay, they're probably going to be off the mark in the same direction for the future.
Well, just one thing, that the opposite wouldn't necessarily, the converse wouldn't necessarily apply, right? I mean, they could reconstruct the past accurately, and it could just be manipulating variables,
yes.
Right?
Yes, and the IPCC actually points that out in a number of places when they say, okay, even if you get a decent replication of the past, it doesn't mean the model is going to do well in the future, and that can be shown on various levels. But if you have a model that's consistently over predicting observed warming trends in the past, unless you have a really good explanation of why that is the case, then your default should be it's probably going to be over predicting the future as well, especially if that over prediction is tied specifically to its response to greenhouse gases. So John Christie of the University of Alabama in Huntsville and I have done a few papers on, and I've worked with other authors on this as well, looking at data sets, especially from the layers above the surface, the lower mid-troposphere. Modelers, when they're putting their climate models together, they pay a lot of attention to trying to replicate what goes on at the surface. So the 20th century surface record is kind of a target for them to replicate. And there's tuning that goes on. They don't necessarily just try to calibrate to the surface and get it that way. But the fact that the models all tend to agree on what happened to the surface, to the Earth's surface over the 20th century, even though the models have very different levels of sensitivity to greenhouse gases. And so they predict a lot of different outcomes in the future. And so what John and I have tended to do is say, well, let's not look at how it does at the surface, because the modelers are tending to calibrate to the surface, but let's look at how they do above the surface in the troposphere, where there isn't direct tuning to try to reproduce the troposphere. And what we've shown in a number of papers is it's not even close. Like every single model that's out there over predicts the warming in the troposphere. And between the 5th generation, which was what was used 10 years ago, and the 6th generation of climate models, which is what's being used for the next IPCC report, the gap has gotten worse. And other studies have pointed out that as the successive generations of models come out, they're getting closer and closer to each other, but in the process, they're also getting farther and farther away from the target observations. And another issue which modelers have published about, which is they're puzzled about and a bit concerned about, is the models exhibit a higher and higher what's called equilibrium climate sensitivity, which is a standard measure of just how responsive models are to injecting greenhouse gases into the atmosphere. And so there's a range of equilibrium climate sensitivity in the models, but from the 5th generation to the 6th generation, the range jumped up. It's still fairly wide, but the top end has gotten even higher. So there's now models that are predicting quite a bit more warming.
So it was 1.5 to 4.5 Celsius per doubling for most of the reports. What is it in 6?
So that range is referred to as the the Charney range was first set down in 1979 by a group working at the National Academy of Sciences. And as you say, the IPCC has kept it as their preferred range ever since. The models, I don't know for the forthcoming report how much they're going to change it, but the upper end will probably go from 4.5 to at least 5. But there are models out there that are over 6. And the bottom end, there's empirical work that has said, no, the bottom end should actually be closer to 1. There's a lot of studies now using the long-term surface and atmospheric temperature data sets that now extend to about 120, 130 years. And have argued that when we look at what's happened empirically, a sensitivity closer to 1.5 degrees sensitivity to CO2 doubling makes the best sense of the historical data. And that also is consistent with what John and I found in our study of the global troposphere, that even the lower sensitivity models now are projecting too much, or are putting too much warming since 1960 into the atmosphere. And so you've got, on the one hand, from the models, however it is that they're being put together, they're getting higher and higher equilibrium climate sensitivity. But in the comparison to the data, we're seeing the preference should actually be at the lower end of the climate sensitivity. And I know I was a reviewer for the forthcoming IPCC report, and I worked on this section and put in review comments. I don't know what effect it'll have, but I know how they're going to try to rationalize allowing the equilibrium climate sensitivity range to go up. It's going to be a bit of a convoluted argument around cloud processes. But to me, it looks like they're at the point where they're having to start adding in epicycles and more complicated mechanisms to try to get away from this basic mismatch, which is the troposphere is really where the warming action takes place in the models. It's a very important layer, especially over the tropics, because there's an important amplification process in the models that happens in the tropical troposphere, and it injects a lot of heat into the global climate system there. And it's that amplification which does not match the observations. It's way too high. And so I think there's a simple story that emerges here, which is the models have too much amplification going on in the troposphere, there's too much warming in the tropics, and now too much warming globally in the troposphere. And the models that fit the data best are the ones that have very low climate sensitivity to greenhouse gases. Eventually, that something's got to give here. I think I've watched this story develop from the early part of the last decade. Initially, the IPCC community said, no, it's just the data sets aren't very good. Give us a few more years of data. And then the data kept coming out on the same note that no, the warming isn't there, at least not as much as you're saying should be. And then there was arguments about how the time series analysis was done, and no, we got that figured out. And then various other excuses have been put forward, but I think they're running their course. I just don't see how the climate modeling community can let this go for another 10 years and watch this gap get bigger and bigger without it. I think without it just being discouraging to the modelers themselves. I mean, I think there are a lot of serious people in that business that want to have good, accurate models. And at some point, I think they're going to start to address this very constructively.
I mean, if you had an equilibrium climate sensitivity of 1.5 or even closer to 1, I mean, it's important to note that this would just totally devastate so many people's livelihoods and purpose for being in the world.
Yeah, that's not how I expected you were going to finish the sentence.
What did you?
I thought you were going to say it would, if it turns out, like if everyone agrees, yeah, actually ECS climate sensitivity is about 1.5 degrees, it would devastate the argument for aggressive climate policy, which would be good news for most people in the world. But yes, I think you have in mind that slender segment of the world's population that profit handsomely from alarmism, and that would be devastating to them. I did a paper with Kevin Diaratna. He's a statistician at Heritage Foundation, and a couple of other co-authors. We did a few papers looking at, okay, what if we take this empirical version of the equilibrium climate sensitivity number from the climate literature, not our work, it's from the climate literature, and plug it into the integrated assessment models that economists have been using to calculate this number called the social cost of carbon. Instead of using the standard IPCC range, the 1.5 to 4.5 degrees, what if we use the empirically constrained range? Well, the social cost of
what
carbon,
is exactly the empirically constrained range?
I believe it's I believe the one we used was 1.7 degrees plus or minus 0.3 degrees. I'd have to check.
Gotcha. Okay, it's on that order. Okay,
it's on that order. Well, the estimate of the social cost of carbon collapses. It basically goes so close to zero, it might as well be zero. The models that we used, we took what are called integrated assessment models, but they're the ones that were used by the Environmental Protection Agency under the Obama administration to generate its estimates of the social cost of carbon. And the models get tweaked in various ways, and the people who build them are always looking for ways to update the parameters and change things. But ironically, they haven't touched the ECS parameter, this equilibrium climate sensitivity parameter. It's always left at 3 degrees plus or minus 1.5 degrees, and then they generate the results using that. So I thought, and Kevin worked on this as well, and we both just thought, no, you got to pay attention to what's going on in the literature on the climate side here. And it's not just one study that said, look, ECS appears to be around 1.7 or 1.5. There's a dozen studies out there that have come up with numbers in that range. So when we put that range in, as I say, it has a dramatic effect on the social cost of carbon. It drops it to under $10 for decades into the future. And at that level, it's such a small amount. Essentially, the economics would say, you can't justify spending any money on CO2 mitigation if the social cost of carbon looks like that. And I think that was it was a very important way of tying together what we've been talking about on the modeling side, the model testing issue, with the point where it actually impacts people's lives, which is what's the policy agenda? What's the justification for some of these incredibly expensive policies that are being put forward in the name of climate change?
Yeah, it's another, well, the climate economics it's an interesting thing. You know, I'm sure you're familiar with Richard Toll, and obviously Nordhaus is the most famous one. And there's just an interesting backlash from the climate catastrophist community. Like, in my view, you know, from my vantage point, Toll and Nordhaus are, like, I consider them climate catastrophists relative to myself. Like, I have issues with them in that direction, but the climate catastrophist community, like, thinks of these guys as they're ruining everything. And I think that climate economics, so I think what happened is the catastrophists wanted the imprimatur of economics on things so that they could make these projections. But then you have these economists, and they're actually trying to evaluate, okay, what's this actually going to do to human life and human values, and how can we measure this? And so even if you take some of these more extreme kinds of assumptions, like higher climate sensitivities, like, the economists were not getting what the catastrophists wanted to get them. And people like Bjorn Lomborg have made a lot of hay out of this and said, hey, like, okay, even in this scenario, it's not remotely like the end of the world. Nobody's saying that. And so now it seems like there's this, I think there is this thing to sort of invalidate at least certain climate economists and look for more catastrophist ones. What's your take on what's going on and how that might play out?
Yeah, well, I did my graduate studies in economics in the early 1990s. I was working on the climate change issue from then to now. And in those days, it was quite common for the economists who looked at this issue to point out that, okay, notwithstanding that some models could give you high-end risks to the global climate. Fossil fuels are so valuable to society and to the economy, and most economic activity is so unaffected by the climate. It happens indoors, and it happens already in any temperature zone you care to mention. So it just didn't look plausible to expect that the damages of CO2 are ever going to be high enough to argue for any kind of major deflection of the global energy system. And it's worth looking back to a 1992 speech by Thomas Schelling, who was the president of the American Economics Association at the time. It was one of the first big addresses on the economics of global warming. And he pretty much came out and said, adaptation is probably the way to go. And it certainly doesn't make any sense for developing countries to try to stop global warming. They just need to prioritize growth and development. And since then, things didn't change all that much from that. And I know people in the physical sciences have been baffled by economists like Nordhaus, who've seen, from their point of view, they say, well, you've accepted all the science. Why do you keep saying we shouldn't do anything about it? And in effect, his argument has been, yes, we should price this externality. There's positive social harm from it. But when you work out what the reasonable price trajectory looks like, it's not really going to change our use of fossil fuels, maybe 100 years from now. But for the next few decades, at least, if you built that social cost of carbon into the price, you'd hardly notice any behavioral changes as a result. And that's partly because demand is very inelastic for fossil fuel use. People don't tend to respond to price changes all that much. And Richard told the same way. And those are two authors of these integrated assessment models that have been very influential, and there's some others. When Nordhaus got the Nobel Prize in economics a couple of years ago, I think initially there was this great reaction on the part of the environmentalists who said, hey, look, this guy does climate economics. Finally, the Nobel Committee has said, this is a huge issue, it's an important issue. And then maybe they had this follow-up reaction when they looked at what he was actually saying, and suddenly there was the discrepancy was, but he's not saying what you guys are saying. He's not saying you got to phase out, go to net zero, you got to get rid of fossil fuel use. And so he's come in, as you've pointed out, he's come in for a lot of grief, Richard Toll and others. And yet, if you were going to make one of those integrated assessment models, come back with results that say, yeah, we got to accelerate the transition away from fossil fuels, we got to get to net zero in a hurry, you'd really have to distort them in such a cartoonish fashion that I just don't think anyone would view it as credible. I'm sure people are trying to do it, and there are studies that come out that say, well, if we tweak this and we add in some catastrophe risk and this and that, we get really high social cost of carbon numbers. And as soon as you get to like $400 or $800 or $1,000 social cost of carbon, then yeah, all right. If you put that in place as a carbon tax, you're pretty much going to wipe out your fossil fuel based economy. But the assumptions necessary
with the fossil fuels and the economy, I should say.
Yes, you'd wipe everything out. I mean, it wouldn't be pretty. It would, I think, it would rival World War III as far as the damage to people's lives. But to get those kinds of numbers out of social cost of carbon models, you have to just put in such outlandish and implausible assumptions. One of the tricks that's been used is to say that, well, somehow a bit of warming has a really negative effect on productivity growth and economic growth and capital accumulation. So your growth rate goes from, say, 2.5% per year, it goes down to like 0.25% per year or something along those lines. So it's a small number for a single year, but compounded over 100 years, that means massive costs in the tens of trillions of dollars. And then you can back that out and say that justifies much more aggressive policy. That's the kind of stuff that the special report on 1.5 degrees of warming latched onto. A couple of studies along those lines. There was already stuff in the literature back then that said, no, we don't get costs that high. But since that time, there's been even more that studies that have come out and just said, looking in more detail, looking at longer data sets, the negative effects of CO2 on growth just are not there. It's not a robust estimate. You can't go down that route to justify the radical policy agenda.
Yeah, I mean, as against the negative effects on growth of radically restricting energy use.
Right. Yeah, and it's kind of an odd thing. I was asked not long ago. Somebody said, "Can you point me to a literature that explains the benefits of fossil fuels and the importance of fossil fuels?" And I said, I guess it might be out there, but to be honest, I can't really think of it. Nobody would think of researching it because it's such an obvious point. It would be like asking, can you point me to the professional mathematics literature on proving the 8 times table? It's like, well, no, nobody bothers with that because it's so trivially true. And there are studies that have looked at certain aspects of the role of energy on growth and the importance of energy on growth, but just that global question of, could we have had the growth of the West and the prosperity that we have without fossil fuels? I'm not sure anyone's really done that, or if they have, they've just presupposed that no, we couldn't have, and have gone on from there. But as a result, I think we're now at a point where people kind of take for granted that there's this historical trajectory that we could have been on, which never would have involved fossil fuels, but we would still have arrived at the same level of prosperity and global growth that we enjoy. And that one, I hope somebody out there could just go back, and I know it's such a basic question, it hardly needs to be looked at, but somebody should go back and say, well, this is what the world would have looked like if we were still relying on wind to power our ships and wood to heat our homes and just water powered grist mills to make our food supply. Then this is what the world would look like.
Well, I'll be curious if you read my next, Moral Case for Fossil Fuels talks about this a little bit. My next book, Fossil Future, has an extended discussion of this issue in terms of like explaining the hockey sticks in terms of fossil fuel use. And a term I use is two related terms, but the vicious circle of unempowerment and then the virtuous circle of empowerment. Basically, vicious circle of unempowerment is, when you don't have machines to produce radically expand and amplify your ability to produce different kinds of values, you can barely produce enough to nourish and protect yourself. And that takes up all your time. And so you don't have the time that is necessary for innovation. And you also don't have what I call the machine labor, the use of machines that drives innovation. If you look at innovation today, what is it? It's human beings with time using machines to innovate. And so that's how I see it, as like directly causal. Like once you start having these machines that can produce our basic nourishment and protection, then you start freeing up time and resources for innovation. And that's, and it's just this virtuous circle. But human history is just everybody is focused on their basic needs. And there's just very, very little time to innovate. That's why so much of the innovation historically just comes from a very, very small group of people. And then once you have this ability to produce low cost, reliable energy, then you can start to innovate with that ability. Obviously, there's no ability to innovate with that in 1700 because it doesn't exist. So yeah, I just think of it as, it is interesting though that you say it's like trivial, it's true, nobody's interested in it, but this is the thing that we're talking about destroying.
Yes. You've probably seen Hans Rosling's terrific video on the magic washing machine.
Yes, I have.
Yeah, and I show that to my class each year, and he makes that point that for them, the gift of the washing machine was the gift of time, and then they had time to read books and to go to the library and begin learning and His mom had time to teach him to read, and this gift of time, people don't understand. If we didn't have fossil energy and machines doing all this work for us, your day would be taken up with just subsistence. And the role of machines, it's another one of these aspects to it, that what fossil fuels does is it gives us this very concentrated energy through combustion, which could then be harnessed by machines to give us transportation and all the other things that machines do. And even now, with all our knowledge, we struggle to conceive of replacements. In Ontario, we had a very sad episode of trying to replace a couple of coal-fired power plants with wind and solar renewable energy systems. And it's a multi-layered disaster, which led in the end to much higher electricity prices, but also we've had to add a lot of natural gas fired generators to our system just to keep the lights on. And the closest, I guess, people can come to a non-combustion replacement energy right now would be nuclear. And yet, for some reason, environmentalists are against nuclear. And I just had a conversation not long ago with someone in France who said the government has made a policy decision to begin phasing out their nuclear plants and replace them with renewables, wind and solar. And that I just don't get at all. It's absolute madness to me why they would do that. Well, I'm sure you would have more insight into the thinking there. But I told the person I was speaking to, like, I don't understand that. There's no environmental benefit, and renewables just don't work as well, and they're much more expensive and unreliable. So you'll probably end up having to add natural gas to your power system.
Yeah, not probably.
Yeah,
probably. I mean, it's just, yeah. I mean, it's weird. We have this language. We have this language of interchangeability with regard to energy that I think is very dangerous. You know, because first of all, we talk about energy, and it's often just, there's an equivocation between energy and electricity. So people think, oh, like if we talk about electricity and energy, those are the same thing. So if solar and wind can provide electricity, even if they could do it reliably, that's the same. But of course, we have, high density mobile energy, which is mostly not electricity for reasons of energy density. And then we have, industrial process heat, which is in most cases by far most cost effective to make by directly burning fossil fuels versus turning any fuel into electricity and then turning it into heat. So there's that whole thing. But then on top of that, we conflate reliable and unreliable. And so we treat it as, like solar electricity, that's a thing. That's not a thing. There can be solar plus battery, which is so absurd that nobody uses it, but it's mainly gas plus solar or gas plus wind. And so those are the real things. It's like you can have nuclear or you can have gas wind or gas solar. And so France is replacing nuclear with gas wind and gas solar.
Yes. Yeah. And I know that some of the renewables advocates now are saying, well, no, we've got storage technology coming. And so you can build giant uphill lakes and pump the water uphill and store electricity that way, or battery systems or hydrogen. Maybe one day, I don't know if any of those would ever scale up to a usable level, but if they did, they'd do so at such an incredible cost that you're then talking about, like, it's bad enough that in Ontario, we replaced coal-fired power that we could get at 5 cents per kilowatt hour with wind that we had to pay close to 14 cents per kilowatt hour. But that's to get the unreliable wind. If we want the reliable wind, and that means building storage facilities, I don't know, gets up to $1.50 a kilowatt hour. So in the end, as you say, you have to compare equivalent levels of reliability, and to do so without natural gas, if it's even possible, I think the costs are just going to be so spectacularly prohibitive. I hope before too long, people decide that that's not a good idea. But unfortunately, there's so much absolutism around CO2 emissions. Here in Canada, as well as in the US and pretty much everywhere, there's this kind of absolutist mentality that any option going forward that involves greenhouse gas emissions just has to be driven to zero. There's no safe level. We're just going to propose to get rid of it all, whatever the cost may be. And that's such a huge departure from any rational economic way of thinking about this, that the groups involved, I guess, just talk past each other. And it's very unfortunate because these are very consequential decisions that are happening. And I think they're ultimately going to be quite harmful for people, as long as there remains this inability to think about it in terms of rational trade-offs.
I think, to end on one heartening note, I mentioned how there's this pressure against the economists, but the bringing in of economists, I think, could be one of the undoings of the climate catastrophe movement, even though it was a strategic ploy, because the climate economists aren't doing what they want. And you have a lot of people, Nordhaus above all, who've been raised to positions of prominence who aren't catastrophists. And I think the core reason they're not catastrophists is because they're not on the anti-impact religion of modern environmentalism, which says that impact is intrinsically wrong. So of course it's inevitably self-destructive. And with CO2, that means any CO2 emissions are bad. And in fact, we need to get back to where we were before we influenced any. So we need to get back to 280 parts per million from 420. And that is this religious goal that takes precedence over every other thing. Whereas there's nothing in economics. There's no economist who will say, yes, the goal that we're optimizing for is a pre-industrial CO2 level. They're implicitly saying some form of human well-being is what we're measuring. And I think that's the key difference between the economists and then the so-called environmentalists, or the anti-impact movement, as I would call them. And I think it's great that the economists have been brought in, because as soon as people start thinking in terms of trade-offs or weighing, they're implicitly looking at it from a human perspective, and they're rejecting this anti-impact religion. And I think what you see, with people getting more attention, like Bjorn Lomborg or Michael Schellenberger, is they're starting to bring this more economic way of thinking to things. And I think that's bringing in a lot more people, because it's basically saying, yes, let's incorporate what's known about climate, including that we do impact climate, and let's try to figure that out precisely. But even if we impact it in a way that's net negative, we still need to look at the bigger picture. And I think the more that holistic pro-human way of thinking gets invoked, the less of this catastrophism is going to be there. So of course, there's so much catastrophism now, and net zero is such a dominant cultural goal that can seem hopeless. But I do think that a lot of more rational people are gonna be won over by the more economic way of thinking.
Well, I hope so. I think ultimately 2030 is our next big marker, because so many governments have committed to implausible emission reduction goals by 2030. Canada is an example. And also have done so by telling the public, we have to do this because if we don't, we face a geophysical catastrophe that will be upon us by 2030. And, I'm sure you've seen the websites that have a lot of fun with all the catastrophe predictions of the past coming up to the present. But in the last few years, the whole climate emergency movement, the whole climate emergency rhetoric went so far off the top, over the top, in scaring people and saying there are nightmare scenarios that will be upon us if we don't slash emissions radically by 2030. And well, the problem is 2030 is going to be here before you know it. And when it's here, global CO2 emissions will not have gone down, even if some Western countries put in place much more expensive policies than they've done in the past. China and India and the Asian countries, they're going to keep developing. Africa's building a lot of coal-fired power plants. So globally, emissions are going to keep going up. And I think it is pretty much a dead given that we are not going to face a geophysical catastrophe, and the climate is not going to look much different in 2030 than it does today. And so I don't think it'll happen in the near future that the economic perspective is going to come to dominate the discussion. Economists really haven't changed their messaging on this very much over the past 20 years or more. But I do think that by the end of the decade, maybe more policymakers will decide that this is really unproductive to be scaring people with these ridiculous projections, promising things that can't be delivered, and then everybody's unhappy at the end of it. So
and
maybe
during,
later this decade.
I should add, it makes people miserable now.
Yes, it does. It makes everybody miserable. And so maybe by the end of this decade, there will have been a big reconfiguration of this discussion, and people will, as you say, talk about it in framing in terms of what are the trade-offs involved that maximize human flourishing, and not some abstract zero impact goal.
Great. Well, you've been a great asset to me and to many others. So I'm grateful for your continued participation. Where can people learn more about your work?
Pretty much everything I do is posted at rossmckitrick.com. So that's the best place to start.
And you're also on Twitter, right?
I am on Twitter, yes.
At Ross McKitrick. You won't get any trolls from my audience, probably.
No, I'm sure I won't. I am on Twitter. The last few months, I realized I haven't actually been doing a whole lot on Twitter, but I'm there, and occasionally I get inspired to opine on that forum.
All right. Well, I follow him on Twitter, so maybe listeners want to as well. Thanks so much for coming on the show, Ross.
Thanks, Alex. My pleasure.
Thanks again to Ross McKitrick for joining me. As I said at the outset, I really enjoy how precise he is and how careful a thinker he is. I think that emerged. So he's one of the people I really trust when I ask questions that I'm going to get an objective answer. And I think, as you saw, when I would ask him about, hey, what does the other side say? He was good at summarizing their perspective and their argument, and then giving why he thinks they are wrong. This is something also Stefan Henna, who works with me, head of research at Center for Industrial Progress, is really great at, and one of the reasons why it's great to have him. I've gotten some requests to have Stefan back on the show. I need to do that soon. He's doing a ton of stuff for me on energy talking points work and on fossil future. So in the not too distant future, though, I'll bring him on, and there's lots of interesting stuff we've been working on and discussing. All right, that is it for this week. As always, if you have any questions, comments, love mail, or hate mail, you can email me at alex@alexepstein.com. If you want to support our research and development and promotional efforts at the Center for Industrial Progress, you can become an accelerator. Go to industrialprogress.com/accelerate. Make sure you're on my mailing list, alexepsteinlist.com. And you can follow my latest talking points on energytalkingpoints.com, as well as twitter.com/alexepstein. Also, something I figure I should do is encourage people, hey, if you know anyone, not if you know anyone, well, recommend this show to people, but also leave a rating and review on iTunes or the equivalent podcast platform, or I guess you could recommend my Improve the Planet page, youtube.com/Improve the Planet. On YouTube, where some of you are watching this now, but it would be great to have more and more listeners to this show. Also, a reminder, this week, the book Unsettled by Steve Koonin comes out. It's been, I think, an advance big bestseller. I'm really excited to see what kind of impact that makes. And, the more of these rational, pro-human perspectives come out, the better. And, at some point in the fairly near future, Fossil Future will come out. And I think that will, I think you guys will really like that. So thanks everyone for continued support. I'll be back next week with another great guest. Until then, I'm Alex Epstein. This has been Power Hour.
Power Hour. Life, liberty, and the pursuit of energy. Power Hour. The antidote to shallow thinking about energy issues.